We'll proceed in pseudo multivariate calculus, and we will see little more into the volume calculation. Pseudo multivariate calculus, in which we are pursuing the discussion, and we will proceed in the calculation of volume. So calculation of volume, that we are proceeding. How to calculate volume? Calculation of volume, when we see, it is nothing more than area into height. What is the area? Then width into length is the area. What is area? Width into length is area. Okay, what is complex area? What do you mean by complex area? This is complex area. Okay, this is complex area. Considering this as a sphere, I have another sphere. Okay, considering this as a sphere, this is a sphere, right? Okay, more or less it looks like a sphere. Considering this as a sphere, then what is the surface area of the sphere? Okay, if area comes into the picture, if area comes into the picture, if area comes into the picture, then it is width into height. Can someone tell me where is width and where is height? It is completely round. Consider this is a sphere, then it is completely round. If it is completely round, what is area of this? This is called pseudo multivariate calculus. Pseudo multivariate calculus, Pseudo multivariate calculus means whatever problem we see, solution is hidden in the simple mathematical equation only. If someone is saying, if someone is asked, can you please calculate the surface area of this? I'm 100% sure that he will start sweating. 100%. But if I ask that person, can you calculate surface area of this? Then he would jump. Yes, 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 I know. Width into length is the surface area. Okay. Means how to calculate a very complex thing through normal mathematics. That is known as pseudo multivariate calculus. Pseudo or abstract multivariate calculus. In abstract way, we decide of the thing. Okay, this can be also called a generic program. Generic programming means we are doing programming that is generic in nature. Okay, we are writing a code program that is generic in nature. Okay, what else you are following? Anyone would ask me. I understand your generic programming. What else you are following? We are following a design principle called close for modification and open for extension. Whatever code we are writing, we are not going to change it. It will be extended, not changing it. So if someone need to calculate the surface area, then we have seen that from the width into length, if I start, then width into length will be transformed into A vector into B vector, or width vector cross product with the length vector, W vector, L vector, or A vector cross B vector, whatever the magnitude is the area of a rectangle or parallelogram, where A vector and B vectors are, they are vectors, they are kind of two sides of the parallelogram or rectangle. Okay, A vector, B vector, cross product, calculate the magnitude, you get the area. Whatever the direction of this cross product shows, that is direction of the area, and that is perpendicular to the surface. So this much we have seen. At the end we saw that the area vector, now A vector can be represented. If I see A vector, okay, A vector, if I see, okay, if I say Okay, so A vector cross B vector. So A vector cross B vector. Okay, now if I have a shape like this, if I have a shape like this, and then if I consider this as A vector, if I consider this as A vector, and if I consider this as B vector, okay, if I consider this as A vector, if I consider this as B vector, this is A vector and this is B vector. Cross product of A vector and B vector gives the net surface area. If A vector can be represented, if this is origin, then this consider this point is x1, y1, z1, and this point is x2, y2, z2. Then A vector is x1i plus y1j plus z1k, whereas B vector is x2i plus y2j plus z2k. Now A vector cross VB vector gives the surface area x1i plus y1j plus z1k cross product x2i plus y2j plus z2k. Or if someone is taking even primitive, if someone is calculating even primitive, then it is the magnitude of A vector and B vector multiplication is the area. Means x1 square, I'm sorry, if someone want to go with the even primitive, okay, if someone wants to go even primitive, if someone wants to go, then someone would say length, width into length is the area. What is width? If this is origin, then this point is x1 square plus y1 square plus z1 square. If this point is x2, y2, z2, then this is x2 square plus y2 square plus z2 square root. Then area is x1 square plus x2 square plus I'm sorry, x1 square plus y1 square plus z1 square root, that is the width length, into x2 square plus y2 square plus z2 square root. X1 square plus y1 square plus z1 square root is the length of a vector also. I would rephrase it. I am calculating area of this. I am calculating area of a sphere, but it would be very difficult for anyone. In that sense, we start by area of a rectangle, that is the simplest. And area of a rectangle is width into length. Width, if this is origin and this point is x1, y1, z1 and this point is x2, y2, z2, then width into length is x1 square plus y1 square plus z1 square root into x2 square plus y2 square plus z2 square root. This x1 square plus y1 square plus z1 square root is nothing but it is the magnitude of a vector, that is xi plus yj plus zk. Similarly, another is magnitude of a vector, that is x2i plus y2i plus z2k, x1i plus y1j plus z1k, x2i plus y2j plus z2k. Okay, these vector magnitude is x1 square plus y1 square plus z1 square root, x2 square plus y2 square plus z2 square root. In that sense, the magnitude of vector, this vector, if I say this A vector and B vector, then A vector, how we proceeding? Length to we came to vector. A vector magnitude into B vector magnitude is the net area. Or if I go more deep into vector, then A vector cross B vector magnitude is the area. A vector magnitude into B vector magnitude is same as A cross B vector magnitude. Same thing, provided angle is 90 degree. Okay, it is more generic that if I don't take 90 degree, then it is more generic area, that is A vector cross B vector, and calculates its magnitude. Even though angle is not 90 degree, it will give the area between these two vectors. So we came that our area vector, now earlier we were calculating area magnitude. Now our area vector is A vector cross B vector. Now A vector is x if I denote both A vector in x1I plus y1j plus z1k, B vector in x2I plus y2j plus z2k, that is B vector. Now, if I take out x here and here I take out y, okay, now consider A vector is xi plus yj plus zk and B vector is xi plus yj plus zk in generic form. If I take out x from here and if I take out y from here, it becomes I plus y by xj plus z by xk bracket close into x cross product x by yi plus j plus z by yk into y. Okay, now division will turn into differentiation and multiplication will turn into integration as per the calculus, primitive calculus fundamental. Now in that sense, first one becomes I plus dy by dxj plus dz by dxk bracket close into x into dx cross product again bracket dx by dy I plus j plus dz by dyk bracket close into y into dy. Okay, if someone proceed calculating this cross product, first mind it that in Cartesian coordinate system, z is dependent component and xy plane is independent component. That is Cartesian coordinate system in 3 dimensions. Z is dependent component and xy is independent component in 2 dimensions. Y is dependent component and x is independent component. In 4 dimensions, density is dependent component and x, y, z is independent component. If that is the case, then dy by dx will be 0 because y and x are not related, and dx by dy will be 0 because they are not related. Now it becomes I plus dz by dxk bracket close dx cross product with j plus dz by dyk bracket close into dy. If someone proceed upon it, then area vector is minus dz by dxi minus dz by dyj plus k bracket close into dx dy. This is called area vector. How to calculate volume of this? How to calculate volume of this? Then we will go with the multiplying it with the z vector. Multiplying it with the z vector. What is volume? Okay, we will tell the complete story. What is volume of this? What is volume? What is volume of this? Okay, if I consider this as xy plane and xy plane intersect it at the middle, where top hemisphere is above the xy plane and bottom hemisphere is below the xy plane, and this is centered at origin. Center of this sphere is exactly on the xy plane. I have a center here. They match here. So 0 comma 0 comma 0, that is the origin, is center of this sphere. Okay, in that sense, if I calculating in that sense, then what is volume? The surface area into height. Surface area talks about dx dy. It is in variation of dx dy. If surface area multiply with the height is the volume, or on xy plane, if I take surface area and multiply with the height, that is the volume. These things we have already discussed anyway. We will proceed on this. So, what is height vector? Height vector is zk. Height vector is zk. No, no, no. You tell height vector as the way you started with the a vector and b vector. Looks like your volume is z vector dot product. A cross b vector is the area vector. If A is A cross b vector is the area vector. If I say if I say that I have another vector called z vector, I have another vector that called h vector. That is the height vector. Then area vector dot product with the height vector is the volume. We cannot do triple cross product. A cross B bracket close cross C. Okay, that will not give the volume. A cross B dot dot the dot with the height vector. The analogy is if I take A cross B in the xy plane, if I take A cross B in the xy plane area vector, then area vector point towards z axis. Then again cross product with the z axis will result nothing. So A cross B dot product with the height vector. So if I say height vector dot product with A cross B is the volume, then height vector consider earlier we took, if I say this as a surface vector, then we started, this is origin and this is x1, y1, z1. This is origin, this is x2, y2, z2. If this is xy, if this is the surface and I'm talking about height somewhere, or this is the surface, then height somewhere, so that we calculate the volume. Then if this is the origin, then this is x2, y2, z2. If this is the origin, then this is x1, y1, z1. If this is the origin, then if I take a height that is perpendicular from this, then this tip is x3, y3, z3, means xi plus x3i plus y3zj plus z3k dot product with the A cross B vector is the net volume. A cross B is minus dz by dxi minus dz by dyj plus k bracket close into dx dy. Okay, if that is the case, then this height vector I can take out z, because we are considering height is varying along z direction. Whatever is varying, we consider as independent component. So height, if I say xi plus yj plus zk, or x3i plus y3z, y3j plus z3k, if I take out z, it becomes dx by dzi plus dy by dzk plus dzj plus k bracket close into z into dz k into dz. Now dx by dz is 0, because along the z, we are taking height considering z as independent component. When z as independent component, then x and y, they are not, they are completely different to z. Dx by dz will be 0, dy by dz will be 0. It comes as k vector dz, means our net volume calculation is dz in Cartesian coordinate system. The net volume calculation in Cartesian coordinate system is dz into k vector dot product with the minus dz by dxi minus dz by dyj plus k into dx dy. Ij will go away. Ij will go away. If Ij go away, it will become k dot, it will become dx dy dz. Dx dy dz, means more or less we are considering our height as a perpendicular along the z axis, whereas surface area, we are taking surface area. I can take surface area along the actual surface area of the sphere, or along the xy plane. If I take surface area on the xy plane and multiply with the height, it will be dx dy dz only. If I take surface area like this and multiply by the z, because z will always be perpendicular. Z will not be like this or like this, like this, because it is a Cartesian coordinate system. It is not a spherical coordinate system that radial vector will go all along from the center. So it will always be dzk. Now in that sense, again it is dx dy dz, and then triple integration. So we have seen it that it will be like dx dy dz and triple integration, where z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Y is minus square root of a square minus x square, because on xy plane it will form a circle if my sphere is centered at the origin. Y is minus square root of a square minus x square to square root of a square minus x square, and then x is minus a to a. Someone can try calculating it. Dz integration is z. Z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. I am repeating it actually. It becomes 2. 2 is outside. 2 into square root of a square minus x square minus y square. Dy dx. If I take y equal to square root of a square minus x square cos theta, dy equal to square root of a square minus x square minus sine theta d theta. Okay, in that sense, this will be transformed into square root of a square minus x square sine theta into square root of a square minus x square minus sine theta d theta. It will become a square minus x square that I can keep outside minus sine square theta d theta. Okay, minus I can keep outside sine square theta integration is theta by 2 minus sine 2 theta by 4. Where is from theta to theta? Theta, now y is minus square root of a square minus x square. Y equal to square root of a square minus x square cos theta. Theta equal to cos inverse y by square root of a square minus x square. Means theta is from minus cos, theta is from cos inverse minus 1 to cos inverse 1. Theta is from pi to 0. Theta is from pi to 0. And then we have theta by 2 minus sine 2 theta by 4. Pi to 0. If I apply 0, all is 0. If apply pi, then it becomes minus pi by 2. Sine theta will go away. Minus is outside. It will become pi by 2. 2 is also outside. 2 is gone. It will become pi. Pi. Now we will bring the kind of a square minus x square. A square minus x square. So a square minus x square dx. It becomes a to the power a square x minus x to the power 3 by 3 minus a to a, or 0 to a 2 times. So I can say 2 pi and then a to the power 3x minus x to the power 3 by 3, 0 to a. That will become a to the power 3 minus a to the power 3 by 3. 2a to the power 3 by 3. 2 is outside. 4 pi a to the power 3 by 3 is the volume. So nice. Anyway, we talked about in past session that can we calculate it through hybrid. Through the spherical coordinate system, we have also seen that the volume is the area vector through spherical coordinate system is r square sine square phi, r square sine square phi d theta d phi. This is area vector. Okay, to get the volume vector, I have to multiply it with the radius vector. That is, I'm sorry, the area vector that we have calculated in the kind of a spherical. Please watch our priceless video. So area vector we calculated in the previous video as r square, where r is constant. R square sine phi d theta d phi r unit vector. Now, if I try to calculate the volume, then area vector into radius vector in a spherical coordinate system. If I talk about a spherical coordinate system, then this is the surface area. And if I say the height means third component. Height means third component. Two components are theta and phi. And for a particular radius r, it forms a surface. If I see the third component, that is the radius vector, from center of it is the origin. From the origin, if I take any point P here, and if I draw a straight line, that is the radius vector. If I do dot product with the radius vector, it will give the volume. If I talk about Cartesian coordinate system, if I have a surface area vector that is in dx dy, whatever it is. If I do dot product with the k vector, that is the third component. K vector, it gives the volume. Similarly, in a spherical coordinate system, if I have an area vector, if I do dot product with the r vector, that is the third component, area vector is d theta d phi. Third component is dr. If I do dot product of it, it will give the volume. What is the area vector? R square means if I take a surface area of this, r square is the fixed radius of this. R square sine phi d theta d phi r unit vector. Dot product with dr r unit vector. How it becomes dr not r unit vector? Please watch our previous video. Now in that sense, if someone does dot product of dr r unit vector dot r square sine phi d theta d phi r unit vector, r unit vector, r unit vector. Dot product will go away. Now net it becomes sine square sine r square sine phi dr d theta d phi. R is from 0 to a, phi is from 0 to pi, and theta is from 0 to 2 pi. Altogether it becomes 4 by 3 pi r cube. 4 by 3 pi r cube or pi a cube again. Anyway, now if I see the hybrid model, a spherical coordinate system, if I take pure spherical coordinate system, any point on the sphere that is P can be represented by position vector, that is r vector plus r sine phi theta vector plus r phi vector. This is what we have seen in big detail, in quite detail. R vector plus r sine phi theta vector plus r phi vector, or r into r unit vector plus r sine phi theta into theta unit vector plus r phi unit vector. That is also a position vector in a spherical coordinate system. That is same as xi plus y. I'm sorry. That is similar to xi plus yj plus zk. If someone is talking about a hybrid model of a spherical coordinate system, hybrid model of a spherical coordinate system, then it becomes xi plus yj plus zk is the position vector of any point on the sphere if I draw an array, a line from center origin to that point. If that is the case, xi plus yj plus zk is the position vector. Now in a spherical coordinate system, x is r sine phi cos theta, y is r sine phi sine theta, and z is r sine r cos phi. Please watch our previous video. In detail to detail manner we have talked how it is. If I have a sphere and this is a radius from vertical, it makes phi angle. If I have a sphere, then radius is everywhere r. Okay, in horizontal plane it is r, in vertical plane it is r. If I take any moment r from vertical, it makes phi angle. So r cos phi is the z. Makes sense? R sin phi will fall on the xy plane. R sin phi cos theta is x. R sin phi sin theta is y. Makes sense? Where theta is angle with x axis when r falls on xy plane. So x is r sin phi cos theta, y is r sin phi sin theta, and z is r cos phi. In that sense, any point on the sphere P connecting origin is xi plus yj plus zk, then it becomes r sin phi cos theta I plus r sin phi sin theta j plus r sin phi, I'm sorry, r cos phi k. Mind it that it is in ijk, even though we are saying r phi and theta. This is a hybrid model. Actual spherical coordinate system no one had talked in the book. If anyone can refer. Means actual coordinate system is r into r unit vector plus r sine phi theta into theta unit vector plus r phi into phi unit vector. That is actual spherical coordinate system. This is a hybrid model. That is r sine phi cos theta I plus r sine phi sin theta j plus r cos phi k. Okay, now if I want a, what is your area vector? Area vector is A cross B. Our A vector is r sine phi cos theta I plus r sine phi sin theta j plus r cos phi k. Cross, again same thing. Now if I want it to represent it as a curve vector, why we take out x? If someone remembers, A vector cross B vector is the area vector. A vector is xi plus yj plus zk. B vector is xi plus yj plus zk. In A vector, I take out x, and B vector, I take out y. In height vector, I have taken out z. We do so because we want a vector in a curve manner. If I say I want to calculate the area of this, then A vector cross B vector is the area. But this surface area is like this rather than a flat surface area. If surface area is a curved surface area, then then this A vector is curve now, and B vector is also a curve now. So in that sense, A vector to A vector, earlier A vector was representing a straight line. A vector to represent a curved line, I took out x, so that internally it will become y by x. Y by x represent the curved line. Similarly, if I have cross product of two vectors, that is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k cross, same thing, is the area vector, then first one is a vector representation in a straight line. If I want vector representation in a curved line, please watch our previous video. If you want vector representation in a curved line, then first side I'll take out theta and second side I'll take out phi, because this vector, they have independent component in theta and phi. So first side, if I take out theta, then it becomes r sine phi cos theta by theta I vector, I unit vector, plus r sine phi sine theta by theta j unit vector, plus r cos phi by theta k unit vector, bracket close, into theta. Cross product, again in bracket, r sine phi cos theta I unit vector by phi plus r sine phi sine theta by phi j unit vector plus r cos phi by phi k unit vector, bracket close, into phi. Now if I substitute division by differentiation and multiplication by integral calculus, it becomes d of, it becomes r sine phi d cos theta by d theta I plus r sine phi d sine theta by d theta j plus r dr cos phi by d theta, that is 0, because phi does not vary with theta. Area vector r is constant. Now in that way, first becomes r sine phi d, r sine phi minus sine theta I after differentiation, plus r sine phi cos theta j. That's it. Cross product, and next will become r d sine phi by d phi cos theta I, means r cos phi cos theta I plus r cos phi sin theta j plus r minus sin phi k, bracket close, into d phi. Multiplication become integral calculus. If someone does this cross product, we have done it during the session 1, cross product of r sin phi minus sin theta I plus r sin phi cos theta j, cross product with r cos phi cos theta I plus r cos phi sin theta I j plus r minus sin phi k into d theta d phi. If someone does this cross product, exactly whatever he gets, this is the area vector. Dot product with the r vector. Dot product with the r vector. What is r vector? What is r vector? Okay, in a spherical coordinate, when we see the surface area in d theta d phi, the third component that will come to for the r vector is the dr r unit vector. How come it is? How come it is dr r unit vector? Means r is a straightforward component in. That's why I don't like hybrid model. If you see the pure spherical coordinate system, I could have taken any point P as r into r unit vector plus r sine phi theta into theta unit vector plus r phi into phi unit vector. If I take out r as independent component, it becomes r unit vector plus whatever by dr plus whatever by dr. Both will be 0 because r does not vary with theta and phi. At the end, it will become r unit vector into r, or r unit vector into dr, a dr r unit vector. Anyway, but if I take hybrid model still, then whatever we talked about, the area vector dot product with the r unit vector dr will be the net. Now, if someone calculates the cross product of the big item what we have talked right now, it will become r square sine phi only. So at the end, the volume in the hybrid Cartesian coordinate, hybrid Cartesian coordinate and this model also. If someone talks about the volume, okay, hybrid Cartesian coordinate, model, then it will become r square sine phi, r unit vector, r the area vector, the cross product of r, cos phi, whatever it comes, it will be settled down in r square sine phi only, and then dot product with the r unit vector. Okay, if someone settle it down, it will become r square sine phi, r square sine phi dr d theta d phi only. What we got in the spherical coordinates. Same we will got in hybrid spherical coordinate system model. It is confusing. I should take I, J, K or R or what. That's why hybrid is not good. Anyway, whatever it is, at the end, the net volume is r square sine phi dr d theta d phi, where r is 0 to a, phi is 0 to pi is 0 to pi, and theta is 0 to 2 pi. If someone settle down, it becomes pi 4 by 3 pi r cube only, or pi a cube only. Anyway, I had thought of starting another thing here, that is, do you, anyone would ask me, do you have any another analogy of calculating the volume or calculating the surface area? What is the surface area? Is there anything in the term of line integral and area integral? People have heard about line integral. Line integral is also called work done calculation. Energy calculation is force vector dot displacement vector is the energy calculation. Area vector, velocity vector dot product with the area vector. Velocity vector dot product with the area vector is called net flux coming out of it. Okay, force vector dot product with the length vector is the energy. Okay, where that is not synonym of the area vector, certainly, because it is a dot product there. But velocity vector dot product with the area vector is can be a synonym analogous to the near to the calculation of the volume. Velocity vector can be a height vector dot product with the area vector which will give the volume. This is called area integral. So what we proceeded right now, that is called pseudo mathematics calculus, where we started from the width into length, that is area, into height is the volume. Can we proceed through line vector or area vector? Means in the sense that work done calculation and flux calculation. Flux calculation is velocity vector dot product with the area vector, or vector field. Vector field means algebraic vector. Vector field dot product with the area vector give the net flux, net volume per second coming out of any surface. Can I use that concept to proceed upon calculation of the volume? That is mind-blowing, amazing. But certainly that is not the pseudo-multivariate calculus. That will be based upon some certain principle that is called flux calculation or area integral. Area integral, line integral, that is a separate term at all. It is not near to the pseudo-multivariate calculus. But with that fundamental also, we will see area calculation and volume calculation. Okay, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.